Welcome to the Aspen Plus version 10 video series. This video series serves as an introduction to Aspen Plus for chemical engineering students studying kinetics and reactor design. In this video, the volume required of a plug flow reactor to achieve a 15% conversion of acetone will be determined. 8,000 kilograms per hour of acetone is fed into a PFR for the vapor phase cracking of acetone to ketene and methane. The inlet temperature is 1000 Kelvin, the pressure is 1.5 atmospheres, and the reactor runs adiabatically. The following reaction happens first order with respect to acetone, with the rate constant as a function of temperature. After opening a blank simulation, input acetone, ketene, and methane into individual component ID cells. Then, in the navigation pane in the Methods folder, select Specifications. Under Method Name in the drop-down menu, select SYSOP0, which utilizes ideal conditions and Raoult's law to run the simulation. Next, click the Simulation tab to switch to the main flowsheet. In the Model palette, switch to the Reactors tab. Then, select the R-Plug block and drag it onto the main flowsheet. Create inlet and outlet streams for the PFR from its indicated red arrows, and name the inlet and outlet streams. In the navigation pane in the Streams folder, double-click on the In folder to access the Specifications menu for the inlet stream. Then specify the temperature and pressure to 1000 Kelvin and pressure to 1.5 atmospheres. Next, specify the total flow basis to mass with a total flow rate of 8,000 kilograms per hour. Then specify the composition to mass frac with a value of 1 for acetone. Next, in the Blocks folder, double-click on the B1 folder. Under Reactor Type, select Adiabatic Reactor. Then, switch to the Configuration tab. To determine the volume required to achieve 15% conversion of acetone, first enter a starting PFR length of 3 meters and diameter of 1 meter. Next, switch to the Reactions tab. Click New to specify a new reaction, and click OK to accept the default reaction name R-1. In the next drop-down menu, select the type of reaction to be LHHW, which will make the cracking of acetone follow a Langmuir-Hinshelwood mechanism. Now, in the navigation pane in the Reactions folder, double-click the R-1 folder. Click New in the Stoichiometry tab. Then, in the Reactants box, in a Component drop-down menu, select Acetone. In the Products box, select Ketene and Methane. Specify the coefficient for acetone to be -1 and 1 for both ketene and methane. Close the Edit Reaction menu and switch to the Kinetic tab. Switch the reacting phase to vapor. Then, in the kinetic factor box, specify the following based on the rate constant. Pre-exponential factor to 1.127, n to 0, activation energy to 284.507 kilojoules per mole, and reference temperature to 1000 Kelvin. Select the driving force option. In the Term 1 box, specify the exponent of acetone to be 1 and 0 for ketene and methane. Then specify the coefficients for driving force constant to be 0 for A, B, C, and D. Next, in the Enter Term drop-down menu, select Term 2. Specify the coefficients for driving force constant for B, C, and D to be 0. Then specify the value for A to be -1 million. Run the simulation. In the navigation pane in the Results Summary folder, double-click on Streams. The mole flows of acetone in the inlet and outlet streams should be 137.7 kmols per hour and 117.4 kmols per hour respectively. This results in a 14.8% conversion rate of acetone. To achieve the desired 15% conversion rate, we must increase the length of the PFR. To do so, access the Specifications menu for the B1 block. Then, in the Configuration tab, specify the length to be 3.2 meters. Then, run the simulation. Switching back to streams in the Results Summary folder, the mole flows of acetone in the in and out streams should be 137.7 kmols per hour and 117 kmols per hour, which results in a 15% conversion rate of acetone. So the final volume of the PFR is 2.51 meters cubed. This concludes the first video of the Aspen Plus version 10 video series for kinetics and reactor design. Please look out for future Aspen Plus videos for chemical engineering students.